Welcome to Pavithra Laptop Care. See, in this schematic, I am seeing something. What is that? It's a W25Q64FVSSIQ. What it is? It's bias chip. It's a 3.3 volts bias chip. So, what's the special in that? So, that is the most important thing we come to know. Okay? See, here, how many legs are there in this particular IC? Total 8, right? 1 2 3 4 5 6 7 8. One is CS hash, second one is DO, data out, write protected hash, ground, DI, data in, clock, hold hash, VCC. See, what are the hash is there? That is the optional. It's enable or disable. Two options will be there. Here it's only one, present or absent, VCC, DO, clock, DI. This is the ground. Okay, so what's the special in this IC, in this video particularly? That is the secret, the major secret going to reveal today. You never ever seen any videos in any institute you had learned. Okay, this video is specially dedicated to our PLC student and especially Mr. Chetan, Mr. Syed and team. Okay, and plus who are watching YouTuber, the serious technicians who want to know the characteristics of this bias IC, because it's very serious thing. Okay, it's not you have seen and you left it. It's not like that. It's a practical experiment and also it's a genuine fact. So what you have seen in this, that you have to realize what it does and in motherboard. Okay, actually how it will read and write in BIOS programmer. Those things, those facts you come to know one by one. So in previous videos I already made it's regarding that 1.8 volts ICs. So again I don't want to go the same repeated video. The main fact, how a programmer will write in a programmer IC, sorry, chip IC, the BIOS IC. That is I am going to show you now. See here, now it's a pin number 1 is CS hash. What is that hash? Hash means what it does. And what about data out and data in? And what about VCC? VCC, once you connect the programmer, will you get the 3 volts? I'm not joking. You are getting or not? That anybody checked in the programmer? Not in motherboard. Motherboard you will get by default. But what about programmer? Once you connect the IC, will you get? Anybody checked? See, after this question, you are going to check. I think so. You will be checking. See, those facts I am going to show in this video. Okay. See, now the thing is in DSO, the pin number 1, I'll keep the DSO probe in pin number 1. I'll read a bias and write a bias in both condition, pin number 1, pin number 2, pin number 3, pin number 4 is ground, pin number 5, 6, 7, 8. All these pins characteristics I am going to show you. Let's do the practical. Here is the bias I have connected. Okay, so now in software, first I will read. Okay, before that I'll keep the probe in pin number 1. Okay, 1 2 3 5 6 7 8. When it will be in read condition and when it will be in write condition, what will be the characteristics in DSO. Okay, the voltages, see, many people will tell as per the schematic you will get the 3 volts here and here and here and here, whatever it may be. But while writing in RT809F or any programmer, what will be the voltages? So that practically I am going to show you. Okay, so now let us start. Now what I am going to do is, first I will keep the probe in pin number 1. See, in pin number 1 there is no voltage. What is that? It's a CS hash. What it means? When voltage will occur in this? See, as per the schematic or in the motherboard, you will get 3 volts, right? Right or wrong? Check practically and check. Tell me that. Okay. So now I am going to do the smart identify. I done. Check the DSO. What changes you will get? See, once again I will do. It's high and low. When it's detecting this particular CES hash is going to high and low. Okay, chip select will be high and low when it's going to select. So it always should be low. First time it goes high and second time it will be low. I already done a video regarding the bias chip. Okay, that you can see. It's long back, I think so. But anyway, see pin number 1 characteristics. When I done the smart identify, then see it's going to high. It's a curve high and then immediately low. So now I'm going to click on read. What are the characteristics of pin number 1? See, it's high and low. When here it started reading, so one time it went high and low. Now it's reading. Okay, till now it's 0. Now it's again high. See, once it's successful and again second task will start, that time it goes high and low. Okay, now auto verifying. Now what are the characteristics of this pin number 1? See, when it's completed, then also it will come high and low. Now read over. I will try write one. Okay, I already opened a file, so I'll try to write it. See, writing time, it's high. Any guess before this? See, while writing only, it's going to high. See how it looks. Writing time, it will be high. 3.3. Start writing. Erasing time it was high. Writing time it was high. But it's not high in verify mode. When it completes, then once again high and low, I think so. But let us check. Yes, it came and went. Okay. Pin number 1, CS hash you have seen. What about pin number 2? Now it's pin number 2, data out. So what will be the characteristics? So now I'm going to do the smart identify. Yes. So the identify time, it shows some data passed, right? So high, low, some frequency was there. When no work, so it's a off condition. Now I'm going to read it. See, pin number 2, data out. How it's showing? Oh, sometimes it's constant, sometimes frequency. Data out, read successful. Auto verify. See, sometimes it's constant, frequency off. This is the this is the read time over, so write also over, read over, I think so. See, this is the read time. Okay, once again I'm showing you, it's a read time, data moving, read successfully, auto verify, it's a high. Okay, again it's moving. Now it's showing where to save. Read over. Now I'm going to write it. Write time. See what's happening here. See the frequency. How it looks. Constant, right? So almost constant. Verify time, start erase, successful. Now it's writing data. How it's writing? See, aliens. It's constant. Started. Yes, done. See, this is a pin number 2, data out. Pin number 3. It's a write protected hash. Okay, smart identify. Yes, it was there. Read time. Read time is showing 3.3 volts. Pin number 3, write protected hash. See, it's a read time and auto verify time. It's constant 3.3 volts. Still it's constant. It's auto verifying. Okay, read time over, and now it's a write time. Writing time, it's constant. It's auto erasing. Write time, it's constant. Without any function, there will be no voltage. Okay, in the motherboard, they will be giving, right, it's a 3.3 volts. But writing time or reading time, initially it won't be there. When process will start, that time only voltage will be there. See some frequencies, distortions or frequencies, so identify, it's very difficult. But voltage is 3.3 volts. Yes, done. See, after done, there will be no voltage. Pin number 3. Now 4 is ground. Next 5. Pin number 5. What it is? Data in. Okay, smart identify. Yes, it came and went. Read time. See, some data came and went. After that, there is no data. Right? It's not moving at all. Data input, nothing is there. When start reading chip, read successful. Auto verify time also, nothing is there. Correct? Yes, correct only. See, when it was ending time, that time it's high and low. Okay, what about write time? Write time is constant, it's coming actually continuously. Data in. It looks, see, it looks like this. Okay, it's continuously moving. Erase time only, it was constant little bit. It's not constant actually moving, but less frequency. Now it's high frequency. Done. So verify time, there will be no voltage at all, no frequency at all. Pin number 5. Done. See, done time also, it came and went. What about 6? 6 is clock. Okay, now smart identify. Yes, came and went. Now it's a read. Continuously clock is moving on. See the bigger clock, sawtooth waveform. Believe it or not, this is the first time I'm saying this. Till now I was teaching there will be 3.3 volts, that's it. But while programming, I never showed to anyone. That's a fact I'm telling. Believe it or not. Now there is no. Then I'll start writing. Sawtooth. See, there will be a gap. Continuously moving. It's jumping actually one place to another. 8-bit. See this 8-bit clock. I'll show you one more time. 8-bit it's moving. Please see this very carefully. 8-bit is moving. One more time I will show you. Just a minute. After finishing this, again I'll start writing and you observe this 8-bit. Now I'm going to do write again. See the 8-bit 1, 2, 1 2 3 4 5 6 7 8. Okay, 8-bit data moving for 8 through this 8-bit sawtooth clock. The data is moving. Okay, this is how the practically data will move. This is final frequency. Once it done, see one more structure you are able to see. Those are datas. Okay, the sawtooth is clock. You come to know, right? Now, so in this particular bias, 8-bit data are moved. Now, what about pin number 7? 5, 6, 7. 7 is a old ash. So what about smart identify? The time came and went slowly. Read time, yes, it's a high, but some distortions. Read time, it will be constant, there will be no frequency, but it's a distorted frequencies are there. So it's a 3.2 volts. Here it's a write protected and hold, both are will be 3.3 volts. Then there is no process, no voltage will be there. When I will start write, the time it started, it raised to high. See, now it's high, constant. Before it was there was some frequencies. Now I am unable to see that. Sometimes only it's coming. Right time as now frequency started. It's a pin number 7, hold. So now you come to know what about ash, hold ash. Okay, now finally frequency. See, without any process, pin number 8, there will be no voltage. Here it showed it's a VCC, it's a voltage 3.3 volts. I kept on pin number 8 only, there will be no voltage. Now smart identify, see, came and went. Read time, it will be high. Write time also, it will be high. So now you note down while doing the process, read and write. That time what are the pins will be high and what are the pins will give the frequencies. These all are in good manner, then you come to know that particular IC is good. Okay, otherwise some faulty. See, there is no voltage. Now going to write. Write time also it's high. It is successful. That's it, guys. So now we have seen it's a pin number 1 2 3 4. 4 is a ground, 5 6 7 8. When it's when it's a smart identify, read and write process. That's it. So one small information, the PLC admissions is going on. If anybody interested, please directly call me or send WhatsApp message or any Telegram message. You're welcome. Thank you very much.